This little clip is going to be about a very important theorem called the Pythagorean Theorem as it applies to the property of a right triangle. So, everybody has heard about the Pythagorean Theorem. The Pythagorean Theorem says that a squared plus b squared equals c squared. Oh, what are those a's, b's, and c's? Oh yeah, in a right triangle, a and B are the legs, and C is the hypotenuse. And Pythagoras discovered that if you squared the value for the legs of the right triangle and added them together, that they would be equal to the square of the hypotenuse. What I'd like to try to show you is an example of possibly how Pythagoras initially did this. And Pythagoras might have done this with a sketch, probably in the sand. And so what I've drawn here is a right triangle with 3 squares off of each of the sides. This square right here represents a square that is dimension a by a, and its side would be a squared. This square right here is dimension b by b, and its area, all of it, would be called the letter b squared. And this square right here is c by c, and its area would be called c squared, because the area of a square is it's side times side. What I think Pythagoras might have done is Pythagoras might have taken this square right here and fit it into the hypotenuse. So I am going to try to take and draw a line that's equal in length to that line right here, and I'm going to move that square over into this. Oops. Let's see if I can make this work. So let's try that again. I'm drawing a line. Well, I'm going to do it without the line tool. So I'm going to put a line right here, and then I'm going to drop a line right here that I hope is equal to that length, and another one right here, and another one right here. And would you envision dropping this square right there into that spot? So Pythagoras might have thought through that in that way. Then this b squared shape, I'm going to cut that into 4 triangles that are congruent triangles. I'm going to cut the square in half first, then I'm going to cut that piece and create a hypotenuse, and then this piece right here and create another hypotenuse. And again, the picture is not great, but each one of these triangles would slip right into these corner slots to fill up the area called c squared. And what I've just tried to illustrate is that this area and this area could get dropped into this area, and that's how Pythagoras may have began initially with the Pythagorean theorem. Most of us use the Pythagorean theorem by taking the square root of both sides of that equation, so that in this case I could find side C by taking the square root of a squared plus b squared. So in question number 1, I want you to find side C, and you would do that by taking the square root of 2.4 squared plus 7.9 squared. If you'd like, type on your calculator 2.4 squared plus 7.9 squared and hit enter. I'm afraid again I didn't do that calculation, but get that number, and it's going to be about, I don't know, maybe 70, 75 or something. Then take the square root of that 70, 75-ish, maybe 60-ish, and when you take the square root of that number, you would get 8.3. The units were in feet. These values were in square feet, so when you take the square root of something that's in square feet, you're going to get a length in feet. Do the next problem, please. It's real simple. I tend to use my calculator all in one fell swoop. So I tend to find side C, just get the square root symbol, and then 9.5 squared plus 3.6 squared, and I hit enter, and you should get 10.2. These units were in inches, so I got to write those units there. All right, now in question number 3, I want to find side B, not side C. Pythagorean theorem is set up such that I can find side C really well. But if I want to find side B, I've got to get A out of the picture on this left-hand side. So I'm going to subtract A squared from both sides. And now I've rearranged the Pythagorean theorem, and it reads B squared all by itself is c squared minus a squared. Now I've got to take the square root of both sides, and I can find b by taking the square root of c squared minus a squared, and in this particular case side B turns out to be 11.7, and that would be feet. Likewise, if I wanted to find side A in this next problem, I'm going to kind of do this work over here. Similar situation, but this time I want to get A alone, so I'm going to subtract b squared from both sides of the equal sign, and I'll have a squared equals c squared minus b squared. So in order to find a, I'll take the square root of both sides, and a in this problem would be found by taking c squared minus b squared and taking the square root of that, and you should get 0.689. My unit should be in centimeters. Go ahead and do this last problem on your own, but I would tell you that whenever I'm solving for a leg, so whenever I'm solving for a leg, that's A or B, I'm always taking the hypotenuse squared minus the other leg squared under that square root symbol. So in this case, I would take the hypotenuse and square it, and subtract the other leg and square it. Then I take the square root, or do it all at once in my calculator, and you should get 43.5 inches. We'll program this on our Texas Instrument graphing calculator because we'll use it so much when we do our work in trigonometry.